Hi, my name is Abby Bradshaw, and I would like to present to you our work investigating the effect of prediction on perception and motor control during speech production. There are two competing accounts of how prior predictions may be combined with sensory input during perception and motor control. While cancellation models assume that predictions suppress the perception of expected sensory input, sharpening models conversely assume an enhancing effect of predictions for expected sensory input. Previous work has found that participants report clearer perception of expected sensory input during both self-generated finger movements and passive perception of speech, supporting a sharpening account. The current study aimed to test if the same is true for speech production. Participants read aloud words and heard their own voice played back through headphones in real time. We manipulated the expectedness of their voice feedback by randomly perturbing the vowel sound, for example to make the "eh" in head sound more like the "ah" in had. And additionally, we also manipulated the clarity of their voice using a technique known as noise vocoding to give high, medium and low clarity conditions. After each word, they were then asked two questions. Firstly, they were asked if they detected a change in the vowel sound, and secondly, they were asked to rate how clear their voice sounded. This study thus had a 2x3 design, and a total of 21 participants were tested. Our main result was that rated clarity was significantly higher for trials without a perturbation compared to those with a perturbation, and this was true across each of our three clarity conditions, although the effect did get smaller with decreasing clarity. This thus supports a sharpening account. Interestingly, however, this difference in rate of clarity was only seen on trials where participants reported that there was no perturbation, and not on trials where they reported a perturbation. This seems to be driven by an increase in clarity for correct rejection trials, in which participants correctly reported that there was no perturbation. As expected, participants' sensitivity for detecting the perturbation was significantly lower for the low clarity condition compared to the medium and high clarity conditions, which were not significantly different from each other. We also looked at implicit motor responses to the perturbation. Typically, participants will make compensatory adjustments to the way they produce vowels in order to counteract an auditory perturbation. However, we didn't see evidence of significant compensation in our data. In summary, we found evidence for a perceptual sharpening effect during speech production, in which sensory feedback from one's own voice was perceived more clearly when it matches predictions than when it mismatches. We plan to follow this effect up with an fMRI decoding study to look at whether the strength of representations of speech auditory feedback is enhanced or suppressed by prior predictions during speech production. Thank you for listening.